Hi, I'm Bob Tabor with LearnVisualStudio.net. We haven't spent a whole lot of time talking about scope with regards to variables, so I want to more fully explain that concept and then use that as a launching pad to explain the keywords private and public that you've seen several times in relations to writing methods inside of classes. So let me start by saying that whenever you declare a variable in a code block, that variable is only alive for the life of that code block, meaning that when the code block is finished executing, the variable that was defined inside of that code block is no longer accessible, and its values are disposed of by the .NET Framework runtime. So I want to see how this works and how this applies to common code blocks that we've worked with up until this point, and then make a larger application with regard to classes. So I'm going to start by selecting File, New Project, and I'm going to type in the name of our project called Understanding Scope. Click OK. Alright, so what I want to do here is start off with a pretty simple example, and we'll just keep building on it. So I'm going to go For, Tab, Tab, and I'm going to actually make the length 10, but other than that, I like everything about this line of code so far. Alright, so console.writeLine, and then we'll just go I, and then at the very bottom here we'll go console.readLine. Alright, so we know that this is going to work, right? Let's just go ahead and run it real quick. Alright, 0 through 9. Perfect. Now, let's go ahead and access the variable I. Whoops. We're already fighting IntelliSense, meaning that I tried to type in the letter I, it found the first match in IntelliSense, and it found if, and so it won't let me just go straight to I, and so I have to go back here and now manually edit and get rid of the F here. And when I do that, I see a red squiggly line, I see the little blue cursor. We can try to look and see, what do you want to do here? Generate a property? So no. I just want to get to I. Well, see, that's the first problem, is because I is defined within the scope of this code block. Outside of that code block, I can no longer get to I because it doesn't exist any longer. All right? So what if we do this? Let's go ahead and comment that out. That's not going to work. Let's go string j equals an empty string, and then inside of here, let's set j equals I.toString. And then we'll come over here and go console.writeLine j. Now, do you think this will work? We've defined the string j outside of the scope of this code block. Will it still be accessible inside of this code block? Let's run the application and find out. And you can see that second number 9 there. Let's go ahead and remove the ambiguity and just go outside of the for and run it again. And it did, in fact, find the value 9. And the reason this works is because this variable j is defined in an enclosing code block around this code block. So it's still within scope to this inner code block. I, however, was defined on an inner code block, and therefore it's not accessible to the outer code block that contains it. Okay? Let's keep playing with this idea. I'm gonna define a property here, actually a private field. We haven't talked about those yet. Just think of a private property. Okay, that's basically what I'm making here. Property that you cannot see outside of this class. Of course, I'm making it static because static void main is static, and it has to work with static members. All right, so now let's try to do this. And so will this work? We've defined K in an outermost code block inside of the class definition, outside of static void main. Will we be able to see it inside of all of these code blocks? Again, yes, we will. And the reason is because, again, we are defining the variable outside of the inner code blocks. Therefore, all of the child code blocks can see our variable. And so now let's move on to another example. Let's go into the innermost code block and do this. Now hopefully, based on everything we've said so far, you would be able to tell me whether the string, the letter L, will be accessible here in our for loop. Let's run the application and find out. Do you think it'll work? No, it won't work because it doesn't exist in the current context. It does not exist outside of the context of this now innermost code block of the if statement. Okay? Now let's take this one step further. I'm going to go and create a helper method. So static void helper method. And here we're going to go console.writeLine k. Now recall k we defined here at the class level. We called it a private field. We know we can access it from within static void main. We even set it here within the an innermost loop. Can we access it in another sibling method? We'll call helper method, and let's run the application. All right, and so we may have to do this again just to make sure we can see it. And indeed we can. Okay, so again, because k is defined outside of the code blocks where we're trying to access it, it's still accessible. When we get out of the scope of this outermost code block, then not only will we be outside of static void main, but we'll also lose k and helper method and everything else. The program will essentially have ended. All right? Okay, so hopefully if you had any misconceptions about how variables worked with regards to scope, we've cleared it up in this simple example. Let's move on and talk about public and private. In the methods that we've written in previous lessons, we always started with the word public or private, but I never really took the time to explain what that means. They're called accessibility modifiers, and they're used to implement another tenet of object-oriented programming called encapsulation. Now, I really don't want to talk about encapsulation or object-oriented programming, but if I just had to give you a high-level overview, I would say that when you design classes, they should be implemented as black boxes. And so if you think about those old-style television sets, when I was a kid, our family owned a television set, and it had just three simple items on the user interface, I guess you would say. We had a button to turn it on and off, a volume dial, and then a channel dial to get all four television stations, okay? And you actually had to get up out of your chair and turn the dial to change the channel or to change the volume, whatever the case might be. It also had a place to attach an antenna and an electrical cord with a plug on one end, and that was it. Everything else about the television was self-contained, and as a kid I was always fascinated when my dad would pop open the back of the television to fix something, and frankly it always kind of seemed to be a magical device, and even to this day it still kind of is to me. All I know is the public interface that was exposed, the buttons and the dials, and frankly, to use the television set, that's all I need. The same should be true of the classes that we design. All of the important behind-the-scenes functionality, all of the tubes and wires should be encapsulated behind and hidden from the users of the class. They should be encapsulated behind interfaces like public methods and public properties. The class may have private properties, or private fields like we saw just a moment ago, as well as private helper methods that are used to enable all the magic that goes on inside of the class. But the consumer of the class shouldn't have to know anything about the inner workings of the class in order to work with it, in order to operate it. So in a nutshell, private means that the method can be called by any other method inside of the class, but not outside of the class. So you use them to create private helper methods, just like we learned about several lessons ago. All right, so let me do this. I'm going to comment out all the stuff that we did just a moment ago. Let's start over here. We'll leave that intact. And we'll get rid of this too. And I'm going to create a new class. And I'm going to create a public void do something. And then I'm going to create a private string called a method that returns type string called helper method. And this is only just going to return hello world. And then what we're going to do is utilize this private helper method when somebody calls the public do something. Now this is a very simple example, a mundane example, just to demonstrate the concept. You really wouldn't need to do this for a real application, at least something so simple. The notion here again is hiding some things that are used for the implementation of more public methods. Okay, so we will console.writeLine and then call helper method. And then what we'll do here is we'll create car equals new car dot, and you can see that in IntelliSense all I see is the public do something, capital D, we'll come back to that in just a moment, do something, but we don't see the private helper method, okay? And yet it'll still run even though we have no idea that there are private methods being used behind the scenes to implement our public method. Now I want to talk about the naming convention I used, and we spoke about this a couple of lessons ago. Whenever something is public, it should start off with a capital letter and then use camel case from that point on. Whenever something is private, it should start off with a lowercase letter. Now, this is just a naming convention. Are you free to break the convention? Absolutely. You don't have to pay attention to this, but you might do so at your own peril. Other programmers are going to look at your code and say, what were you thinking? Okay, it's just an easy way to identify the accessibility of a given method by looking at its naming convention. The same would be true for variables and things of that nature. Notice that all the variables that I use are all lowercase. Even this private static string, I used a lowercase k. If I wanted to make something public, I would capitalize the first letter. Okay, so just again, a naming convention for you to consider. All right, so what's the purpose of this little pithy example? Again, I really want you to be thinking about primarily using this information with regards to the .NET Framework class library. But whenever you build your own custom classes, you should strive to expose public methods that give a simple, straightforward, obvious usage for your class while keeping other helper methods and functionality privately tucked away and unavailable to prying eyes. You don't want developers fiddling around with the innards of your classes and potentially misusing your class. You want to give them a way to use the class properly through the methods that you've designed. This also removes ambiguity and it makes the usage clearer. So in the .NET Framework class library, that's exactly what happens. Methods and properties are exposed using the keyword public. They might use private methods in private fields, but you would never know that, right? They may use other types of accessibility modifiers as well. There's also something called protected. And a protected method in a base class is visible only to its derived classes, but to no other classes. So you have to derive from the base class in order for that method to be visible to you so that you can override it or whatever the case might be. Private methods in a base class still cannot be seen by the derived classes. So as you can see, the accessibility modifiers like public and private and protected provide different levels of visibility depending on what the author of that class deemed necessary. So just be aware of this. If you can't access something you think you should be able to access, it might be because that particular method is hidden on purpose. Okay, so let's recap what we learned in this lesson. We talked about variable scope, how variables have a lifetime based on the code block in which they're defined. When the current code block is part of the current scope of execution at runtime, then the variable will be available to you. When the current scope of execution no longer involves the code block, the variable will no longer be available. They'll be removed from memory by the .NET Framework's garbage collector. And then we also talked about the accessibility modifiers like public, private, and protected, and how that might impact the way in which we use the .NET Framework class library. And even it might affect someday how we design our own custom class libraries, making sure to hide implementation details and private helper methods behind public method interfaces. All right, so let's continue on in the next video. We'll see you there. Thank you.